Admiral, I'd like to start off the question today by asking you, in your personal list of priorities, what do you think is the head of the list?
As one can see by looking at the variety of ships and aircraft and devices that the Navy operates, the Navy is a highly technical service. I think if you look at the weapon development, for instance, that has occurred over the last 20 years, you see that a very large part of this came from this technical effort of the Navy.
There was a captain back in the old Bureau of Ordnance, and they wanted to start getting into conventional ordnance because the Navy really didn't have any other than the rockets and the bombs that we had. That's when we developed the so-called I series, and there are a whole list of weapons that had I as the end of it.
And now, all eyes on target. Aviation ordnance early on may have looked a little silly, but this development was decidedly deadly, and the dumb bomb would come to dominate the air war for decades. Bombs got bigger fast, and specialized shapes proliferated. But most were designed to be carried internally, in ever-increasing quantities, by aircraft that were, in retrospect, pretty slow. By the late 1950s, a new sort of war was on the horizon. Guerrilla warfare was nothing new, but the U.S. was ill-prepared for large-scale unconventional warfare. All-out nuclear warfare, toe-to-toe with the Ruskies, had been the priority of the post-war Cold War.
Well, boys, I reckon this is it. Nuclear combat toe-to-toe with the Ruskies.
With the recognition that the 1,000-plane raids of the last war were probably a thing of the past, and that there probably needed to be a non-nuclear option for tactical combat scenarios, and that the majority of aviation ordnance in the stockpile was unsuited for modern jet aircraft, the Bureau of Ordnance initiated requirements for new free-fall weapons for the evolving fleet air arm and the evolving nature of warfare. The early 50s had seen the development of the Mark 80 series, 1, 2, 3, and 4, ballistically improved dumb bombs from 250 to 2,000 pounds. Better, and produced in huge quantities, but still more like good versions of the standard general-purpose bombs, the GPs, of the previous war. New free-fall ordnance was required to supplement those GPs, and China Lake was the place to develop the new tools the fleet needed. The World War II rocket R&D effort at Knots spawned a broad-based program of conventional weapons development, a program that paralleled and often complemented the nuclear programs that largely defined the early Cold War era. China Lakers would expand upon their conventional weapons expertise to ensure that the Navy would also have modern weapons that didn't have nuclear warheads. And not only the rockets and guided missiles for which the station was famous. The Knots team designed and developed warheads, and the explosives for them. It had fuses, launchers, and complete aircraft fire control systems in development. It had the industrial base to cast and mill and stamp and machine just about anything it needed. And it had a complete air facility, complete with aircraft and aviators and crews. And China Lake had its own in-house think tank, with unique technical and operational analysis capabilities, and a close relationship with fleet operators. Before the atom-mad 50s were over, Knots would begin a program that would drive the improvement of the brute force dumb bombs and provide better tactical tools to meet the challenge of so-called unconventional and limited warfare. The idea from the outset was flexibility. Shake, bake, deter, dispense, and deny. For every mission, there was to be an I. In an era before computerized aircraft, The eye weapons were to be targetable with a conventional bomb sight and a Mark I eyeball. Software hadn't been invented. The new weapons had to be suitable for high-speed external carriage and delivery, as the piston and prop planes were replaced with jets. They had to be readily adaptable to the increasing variety of tactical aircraft in the inventories. And they had to be amenable to TERS and MERS and other multiple stores carriage configurations being pushed and proposed for the upcoming generation of tactical jets. The new weapons had to be relatively inexpensive, therefore relatively simple too, and designed to be easy to mass produce. Before the end of the decade, China Lake had begun to design and develop a family of modern conventional free-fall weapons to meet those requirements, and the fleets. At least at some point, the names were significant too. Hawkeye became Rockeye, since the original was designed around elegantly modded rocket warheads. FireEye and BrightEye were obvious enough. Big was for binary and wet was filled with liquid. Neither runway ring nor retired vampire skipper, Pad-Eye signified parachute agent dispenser. Den-Eye, the mine dispenser, was for terrain denial. And while the significance of SAD, GLAD, and Snake may have become obscure over the years, series additions like Smoke Eye and Fake Eye and Chaff Eye were pretty clear, as was Mark Eye for target marking, even if those didn't make it much past proposal. Although LBJ, he was the president in 1964, announced them to the public on the very same day, Red Eye and Walleye were unrelated and not part of the Freefall family, save that Walleye may well have benefited from the association in name, but that's a different story. Knots began developing the earliest members of the family in 1959, and the development and improvement program stretched on into the early 1980s, further if you count some eyeless direct descendants. One obvious eye took on the seemingly simple prospect of delivering GP bombs accurately at low level, while surviving the resulting blast and shrapnel. The Snake Eye family of retarded bombs, dumb bombs, yes, in the parlance of today, but it meant slowed down so the airplane could get away, saw 3+ decades of combat. And Snake Eye tails perfected for the 250 and 500-pound Mark 80s evolved into more sophisticated fin retarders, and eventually into fin balloon parachute hybrids adaptable to most of the big dumb bombs. Of the dispenser eyes, only one saw significant employment. Rockeye 2 replaced the more complex and less flexible Rockeye 1 during development. Entering combat in Vietnam, dispensing 247 designed-to-purpose shape-charged submunitions for stopping tanks and trucks and trains, for wrecking radars, and for keeping aircraft on the ground. The 500-pound Rockeye proved highly effective against convoys and anti-aircraft batteries, too, from Southeast Asia to the Iraqi desert. Rockeye's robust design also made it the dispenser of choice for numerous follow-ons. But before Rockeye 2 saw the combat stage, there was Sad-Eye, one of the mothers of the so-called mother bombs. Sad-Eye was a low-drag, multi-purpose dispenser. It was stockpiled, but not fielded. As was the case with its rather oddly favored sibling, the modular universal dispenser, Glad-Eye, which could deliver a bewildering variety of small subs onto the battlefield, from leftover lazy dogs to area denial mines, smoke grenades, and propaganda leaflets. There was Den-Eye, grandfather to today's Gator, which delivered anti-vehicle mines. And APAM, sometimes Rockeye 3, which put 717 advanced anti-material subs into the Rockeye canister. And well in advance of recent crap-off-the-shelf initiatives, Knots took stock tear gas canisters, added parachutes and purposeful fusing, packaged them creatively, and loaded them by the score into Mark 12 smoke tanks to create Pad-Eye, a non-lethal area denial weapon, again, well in advance of recent initiatives for less lethal warfare. There were several deterrent eyes in the series, too. In an era in which the threat of chemical and biological attack was all too real, Wet Eye was stockpiled to make the bad guys think twice about making war with chemistry. And Big Eye, The politically plagued binary weapon system was under development to provide safe storage and carriage for a weapon nobody ever wanted to use. The specialized eyes included, over the years, not only the mission-designed eyes, but numerous proposed adaptations of existing eyes for everything from smoke screening to countermeasures. One very impressive eye was Bright Eye, a 1,000,000-candle-power balloon-borne flare system that could, for a long time, light up a defensive perimeter, unmask an enemy incursion, or enable a rescue operation. Unlike the old firebombs, the ones that are still around, FireEye was designed for multiple carriage at high speed and for better dispersion. It was a unique modular system, efficient to ship and store, and to field fill from available fuels using a mixing unit that was part of the system. China Lake and other labs, the Air Force, the contractors, pursued the addition to some of the eyes of some decidedly un-eye-like attributes over the years. Proposals were floated that would have given rocket motors to some of the eyes, and guidance, too. A laser-guided rock eye was designed for the Air Force. And various guided submunitions were proposed as well. During the 1970s, China Lake developed a follow-on advanced bomb family for the GP function, to finally replace the 30-some-year-old Mark 80 designs with better aerodynamics, vastly improved penetration capabilities, and designed-in flexibility and adaptability to guidance kits. ABF, with controlled fragmentation and advanced fusing, was more effective than anything before or since. And it was designed as an all-up round, combining safety and efficiency. And its highly advanced air-inflatable retarder made for a supersonic snake eye. ABF was canceled before completion, but its direct descendants are out there today in those bunker buster penetrators and JDAM conversions. And lots of those ancient Mark 80s over the years got strap-on seekers too. And data link ties, many of which carry on the legacy of one of the most successful of China Lake's eyes. But that's another story.
Throughout the centuries, the greatest, if not the only, threat to civilization has been man himself. Since his earliest days, the way man has reacted to a situation has created conflict. Generally, we are able to determine when a conflict is limited and when it is not. But we cannot state the precise point when a conflict stops being limited and begins to escalate into war. As man developed the art of warfare, weapon obsolescence began to act as an important stimulus to research and development programs. In the past, relatively slow technological advances allowed nations to stockpile the means for defense. The more gunpowder, muskets, and cannonballs that were stored, the more secure a country could feel. Obsolescence was not yet a critical problem, since the same weapons were useful for many years and in a variety of applications. Time was available after the first shot had been fired to develop and mass produce weapons for war. However, today's world, with its explosively expanding technology, has accelerated the process of obsolescence to an incredible degree. Although it is unlikely that the free world will strike the first blow, it must and is building a strong and invulnerable deterrent weapon system. These strategic weapons remain useful, however, primarily as a restraint to all-out nuclear warfare. The defense picture is further complicated since a complete arsenal of lesser weapons, allowing for immediate reaction to any threat throughout the spectrum of conflict, is also required. The nuclear stalemate has not served to inhibit violence. In fact, it has allowed the enemy to resort increasingly to the use of all types of non-nuclear weapons in the prosecution of unconventional and limited warfare actions. In counteraction to the philosophy of continuing weapon obsolescence, scientific personnel of the U.S. Naval Ordnance Test Station, China Lake, and Pasadena, California, are actively engaged in all phases of the research and development spectrum. Some of
peace or in war, the continued responsibility and survival of this nation depends on the intelligence and discipline of highly trained men and women, advanced research and development, and technically superior weapons. The Navy's free fall program, based on this concept of superiority and preparedness, began early in 1961, when the Naval Ordnance Test Station at China Lake, California, received an assignment from the Bureau of Naval Weapons to initiate the free fall bomb development program. The first task, a retrofix program, was to update and improve obsolete World War II stockpiled bombs for compatibility with high-speed jet aircraft and new tactical delivery techniques. The second task was to develop a new series of air-launched bomb-type weapons. These new weapons were to be the most efficient, destructive, and tactically versatile of any systems yet devised. The objective of these programs was to increase the efficiency and effectiveness of the operating fleet's tactical aircraft striking power. The retrofix effort was concerned initially with 3 types of old bombs which required immediate modification: the ANM-81, the ANM-57, and the ANM-88. One of the first problems to be solved was how to adapt most expeditiously old-type bombs for use on new multiple bomb racks. The solution? A newly designed lug compatible with the MBR. The new lugs are attached to the bomb with steel straps. These lugs have maintained strength integrity in tests to maximum loads of 13,000 pounds. Assembly is simple. Lugs are positioned, straps tightened, then secured by crimping the seals. With this retrofix, bombs designed for use with World War II aircraft have been converted for use in today's modern naval air arm. Another modification project, undertaken by Knott's engineers, involved the low-drag Mark 81 and 82 bombs. Retrofix items which were designed and tested include a governor arming vane for the nose and tail fuses, the arming wire retainer band, and the 1.7 caliber fin sleeves. The most important of these items are the governor arming vanes. Due to increased release speeds and fixed paddle blades, the old fuses on the Mark 81 and 82 bombs would arm within 0.6 of a second, or approximately 15 to 20 feet below the aircraft. This hazard to safety was eliminated by the development of a new and effective control mechanism, which arms the fuse at a safe distance from the aircraft. The new arming vane utilizes air drag and spring tension as counteracting forces to control the pitch angle of its paddles and consequently the rotary speed of the vane. The new vanes give constant arming times at aircraft release speeds from 250 to 600 knots. An entire family of vanes is used to predetermine a variety of arming times, from 2.25 to 10 seconds. These result in a safe vertical separation distance for different weight bombs. The marginal stability of the Mark 81 was another problem. This was solved by the development of the 1.7 caliber fin sleeves, which are fitted over the old fins and secured, thus providing increased flight stability and bombing accuracy. The major part of the free fall program has been devoted to the design and development of new advanced weapons. To date, this effort has created Rockeye, an anti-tank, anti-personnel cluster bomb; Snake Eye, an entirely new bomb retardation concept; Glad Eye, a unique dispenser for a large variety of ordnance payloads; Sad Eye, an anti-personnel, low-drag cluster bomb capable of extensive area coverage; and Wet Eye, an anti-personnel GB or VX chemical bomb designed to carry greater agent payloads with improved dissemination. Let's take a closer look at these 5 new weapons. The Rockeye Mark 12 anti-tank cluster bomb, weight 800 pounds, 90 inches long, diameter 15.75 inches. Rockeye's power punch is 96 6-pound shaped charge anti-tank bomblets with vane arming nose fuses and folding fin assemblies. Rockeye's major units, all interchangeable between weapons, include the fiber nose cone with an integral blast screen. Retro-rocket exhausts impinging on the blast screen provide the necessary force for case bomblet separation. The ejection mandrel, consisting of 8 ejector beams and 6 woven nylon bands. The Mark 16 Zuni rocket motor, which supplies the power for case separation and bomblet dispersion. A 35-inch span stabilizer assembly with detachable fins. And the case, which houses the 96 bomblets, the ejection mandrel, and motor. After the case is separated, the ejector beams are forced outward by the rocket motor, dispersing the bomblets outward at a radial velocity of 10 feet per second. Unpacking and assembling this bomb is easily and quickly accomplished. The weapon is compatible with all 14 and 30-inch bomb racks. Highly effective with its 96 bomblets, Rockeye's impact pattern assures a maximum kill probability. Snake Eye, a retarding tail mechanism for the Mark 81 and 82 bombs, provides naval jet aircraft with a low-altitude, high-speed bombing capability, which eliminates danger to the delivering aircraft from bomb fragmentation. During investigation for the best type bomb retardation system, many devices were studied. All evaluated and rejected for various inherent problems. Out of these studies developed a drag brake tail assembly device which provided simplicity, hazard-free operation and handling, no maintenance, and low-cost manufacturing. Snake Eye is presently designed to fit the 250 and 500-pound warheads and is dimensionally the same as standard tail assemblies. The versatility of its tail mechanism, either open or closed, provides 2 types of accurate delivery modes at speeds ranging from 250 to 550 knots. The pilot, by merely selecting the correct arming switch position, can choose a high altitude drop, utilizing Snake Eye's low drag capabilities, or a low level drop, utilizing high drag capabilities. When in high drag position, Snake Eye dive brake type flaps on the Mark 81 are open to a diameter of 54 inches, affording maximum retardation in flight. Tests have shown that the dispersion of the retarded Snake Eye is as low as that obtained from a clean shape. It exhibits reproducible ballistic characteristics, features unique to this retardation device. Some of the tactical advantages of Snake Eye can be well illustrated by this representative animation. An aircraft carrying Mark 81 bombs, flying at 1,000 feet, would be exposed for a considerable distance to the enemy's radar sweep and also be more vulnerable to anti-aircraft weapons. If the bombs were dropped from 1,000 feet, they would have to be released over a mile away from the target, greatly reducing the delivery accuracy. With Snake Eye, an aircraft can operate effectively at only 150 feet, well below the enemy radar sweep and anti-aircraft fire. Because of the extremely high drag, retardation bombs can be released just 1,500 feet from target. Yet, in less than 4 seconds, the aircraft will have passed the impact point, clear of any fragmentation hazards associated with low-level drops. Because of Snake Eye, new tactical bombing techniques are now under investigation. One of the most universal of all the new free-fall weapons is Glad-Eye, developed to meet naval requirements for an all-purpose dispenser of stockpiled ordnance. This modular type system has a versatile capability for dispensing a wide variety of loads, including chaff or leaflets, lazy dogs, chemical and biological bomblets, and other small munitions, some in existence and some now being developed. Easily and quickly assembled, the canisters latch into position automatically. With a length of over 9 feet, Glad-Eye consists of 7 identical cylindrical sections called canisters, 14 inches in diameter and 10½ inches long. Streamlined nose and tail fairings are attached to the front and rear canisters. The upper portion, the strongback assembly, to which the canisters are attached, houses 7 ejector units. Each ejector is actuated by 2 Mark II Mod O ejection cartridges, which are fired by an electric current sequenced by an intervalometer. The intervalometer also provides for 4 modes of ejection: single, individual canisters fired by the pilot; slow salvo at 300 milliseconds; medium salvo at 100 milliseconds; and fast salvo at 50 milliseconds. After the mode has been determined, the selector switch is rotated to the arm position. The ejection time interval and arming of the weapon are set prior to takeoff. Canisters are ejected from the rear forward. The ejection modes provide flexibility for individual canister ejection or rapid salvo. The strongback is retained for subsequent reloadings. Depending on the type of ordnance carried, individual canister weights will range from 33 to 200 pounds. This will vary the total weight of the weapon from 480 to 1,600 pounds. If leaflets are used, 12,500 can be packaged into each of the 7 canisters for a total of 87,500. Glad-Eye has the carrying capability for 98 M134 chemical bomblets, or 35,000 lazy dogs, 41 caliber sub-missile steel slugs. Providing a variety of employment tactics, this new carrier dispenser concept for ordnance, as well as for advanced munitions now on the drawing boards, is a versatile, highly effective weapon. The 4th new weapon is Sad-Eye, the Universal Dispenser Bomb, Mark V Mod O. Primarily designed to inflict heavy casualties over large areas, it can carry in its weather-tight container large payloads of special anti-personnel munitions. Dropped from Sad-Eye, these special munitions produce a circular ground impact pattern covering several hundred feet in diameter, with a resulting high casualty ratio. Sad-Eye is also an effective dispenser for bacteriological and chemical bomblets. Split longitudinally through the center, the Sad-Eye dispenser was engineered for ease of production and reliable operation. The internal mounting of the arming wire is an important safety feature. Inside the bomb, it is safe from external hazards, such as mishandling or withdrawal forces exerted by the airstream. The nose section of the bomb is secured by a nose locking ring. This ring holds a fuse with a wide time delay range, which is preset on the ground for desired functioning time after release. The bomb case is held closed and supported by high-tension steel suspension bands during storage and flight operations. When the bomb is released, the suspension bands snap off, cleanly separating from the bomb. As it falls, the delay cycle is completed, and the actuator cartridge behind the fuse blasts the locking ring and fuse forward. This action unlocks the bomb halves from the front, and they are ripped apart by the airstream, instantaneously dispensing the payload. Aerodynamically designed to be carried in excess of Mach 1 and delivered at airspeeds up to 600 knots with any of the standard bombing tactics, SADI has a highly predictable ballistic trajectory coupled with a wide variety of munition loads. The fifth I bomb is a completely revolutionary concept in massive chemical bomb weapons. Wet-Eye, developed to increase the lethal payload and improve the dissemination of chemical agents, will be highly effective against personnel in open terrain, armored vehicles, field fortifications, underground shelters, and ships. Keystone of Wet-Eye's uniqueness is that it is formed from the largest extruded aluminum shell ever produced. This tubular shell, with a wall thickness of only 1/8 of an inch, is almost 7 feet long, with a diameter of 14 inches. The tube is shaped and formed into an ogival nose and boat tail configuration. The advanced techniques in metal forming which accomplish this eliminated all longitudinal welds. Thus, leak integrity, compared to other bomb designs, was greatly improved. In addition, the empty bomb weight was vastly reduced. Placement of the strong back on the exterior of Wet-Eye eliminated all exterior welds in the strong back area and provided additional agent volume within the chemical chamber. Wet-Eye is designed with folding tail fins for compatibility with the MBR. Total fin span when open is 34.9 inches. This feature permits 6 Wet-Eyes to be mounted on a single MBR. Wet-Eye's filler plug is designed for automatic, remote agent loading systems. It incorporates 2 soft aluminum balls, which are placed into the tapered filler closure port, then seated tightly under high pressure. This provides a leak-proof system which has not failed in over 100,000 leakage tests. Wet-Eye's metallic nose cone provides covering for the M990 electric fuse, as well as protection against high-frequency radiation. Interim air burst requirements for this weapon will use the M913 electric proximity fusing system. 4 17.5-inch long, linear-shaped charge sections housed in the burster tube assist in dispersing and aerosolizing the liquid agent. The use of linear-shaped charges in chemical weapons is a new and highly successful concept for obtaining greater area coverage with more uniform concentration levels. 8 linear jets are produced by these charges. Another unique feature of Wet-Eye is the stabilized center of gravity. This is achieved by a void control system, which reduces the liquid shift caused by attitude changes. Wet-Eye is loaded in a vertical position. With the forward compartment completely full, the rear chamber, separated from the front by a sealing bulkhead, is left with a 10% void. This void remains in the rear compartment regardless of bomb attitude, because a void control orifice is always below the level of the liquid. But during temperature expansion and contraction, the orifice permits the liquid to flow freely from one compartment to the other. The application of this principle results in increased free fall aerodynamic stability for the weapon. Comparing weight factors and volume capacity of chemical bombs, Wet-Eye's empty weight is 177 pounds. Agent payload, 368 pounds. Total weight, 545 pounds. The Air Force MC-1. Empty bomb weight, 490 pounds. Agent payload, 220 pounds. Total weight, 710 pounds. The Navy Mark 94. Empty bomb weight, 333 pounds. Agent payload, 108 pounds. Total weight, 441 pounds. This ratio of payload weight to bomb weight points up that Wet-Eye carries 69% of its total weight in payload, while the MC-1 carries 30%, and the Mark 94, 24%. Wet-Eye's unique engineering concepts: one-piece tubular construction, folding fins, void control system, high volume capacity, and linear shaped charge for agent dissemination result in a weapon which greatly increases the Navy's capability for chemical air attacks. The free fall program has just begun. For in this mid-20th century, each day, the need for limited warfare weapons becomes greater. We are meeting this need with new, advanced free-fall weapons: Snake Eye, Sad Eye, Rock Eye, Wet Eye, and Glad Eye. And even newer weapons are now under development. Weapons which, when added to our already existing arsenal of freedom, will make this nation even stronger in its resolve and more secure in its beliefs that peace can and will be maintained.
Who was that?
Emory Ellis was the first Caltech supervisor at China Lake. Inyukern then, since his first office was a corrugated steel shell at what's now Inyukern Airport. In fact, Emory was one of the first everythings at Knott's. He designed and often helped execute test range setups. He collected data. He supervised shops building everything from instrumentation stands to privies. And he did dud ordnance disposal when he needed to. He and his wife, Marion, even presided over the station's de facto officers' club at their wartime home at the White Star Mine. Dr. Ellis was one of the makers of the RDT&E Center that China Lake would become, although he may be best remembered for standing midnight guard with his own .38 revolver over the first batch of secret weapons sent for testing at Knott's. Dr. Ellis headed the rocket department at Knott's until 1954, and then worked in industry, in government, and in academia until retirement. But he remained close to China Lake, as a consultant and as a friend, and as someone who every China Laker should remember.
Pad-Eye is a non-lethal agent dissemination system to slow and harass enemy troop movements without harm to civilian population. The dispenser for the Pad-Eye system is the Mark 12 Mod O chemical tank, which is currently used for tactical smoke screens. Within the dispenser are clusters of these grenades filled with a pressed agent pyrotechnic mixture. Either the BZ incapacitating agent or the CS riot control irritant can be generated. The core of the Pad-Eye system is the Mark 278 Mod O igniter assembly, which which is packed in a plastic housing. The assembly consists of the igniter and a parachute. The chute's function is to arm the igniter and slow the generator's rate of descent to prevent injury to ground personnel or damage to the mixture. The igniter assembly is attached to the generator by epoxy. A one-piece plastic module holding 15 grenade igniter assemblies becomes the generator cluster Mark 54 Mod O for BZ or Mark 55 Mod O for CS. An orifice ring used to convert the dispenser to pad-eye use is packed with each two clusters. The standard shipping container can be stored until ready for use. Assembly of the weapon is accomplished by loading the dispenser with 14 clusters individually inserted. The door is secured with an explosive bolt. The orifice ring is placed into the nose and locked into position. A plastic covering will also house the detonator when installed prior to launch. The dispenser, loaded with 210 generators, is attached to the aircraft using standard weapon handling equipment and techniques. A Mark 83 Mod O electric nose detonator and the impulse charge for the explosive bolt are then installed. After plug-in to the aircraft's rocket firing umbilical, the weapon is mission ready. Pad-eye is designed to be delivered by high-speed aircraft at an altitude between 150 and 500 feet and at speeds from 350 to 500 knots. At pilot command, the detonators open both ends of the dispenser, allowing ram air to eject the clusters. The plastic modules disintegrate in the airstream and chute housings spring off. The parachute arms the igniter and reduces terminal velocity to a non-lethal 30 feet per second. Upon impact, the igniter fires and separates from the generator. The grenade burns from both ends for approximately 17 seconds, creating a dense cloud of aerosolized agent. M18 smoke grenades were used to simulate the agent during these tests at the Camp Pendleton Marine Corps base. Under optimum delivery conditions, a single pad-eye weapon will yield a 300-meter long by 15-meter wide ground impact pattern. Average meteorological conditions will cause 30% incapacitation over 70,000 square meters of terrain when using Agent CS. Pad-eye is currently undergoing final certification testing. An igniter modification study is in progress, which will increase the effectiveness of the weapon when used on foliated targets. Pad-eye will soon be released to the Naval Air Systems Command.
Bombs. A key element in aerial warfare. World War II. Millions of tons of explosives and steel. Korea. And Vietnam, where total naval bomb tonnage dropped, was 1.5 million tons, 92% of all naval air ordnance expended. In the 70s, the general-purpose bomb remains the primary weapon of the current bomb inventory. It is an important element in saturation bombing, close air support, area denial, and interdiction. Because of its versatility, low cost, about $1.70 per pound, and good destructive power, the general-purpose bomb is effective against a broad spectrum of targets. Also, the warheads are used in glide and guided weapons and in mines. The general-purpose bombs were introduced in the early 1950s. These bombs are now older than the people who handle them, most of the pilots who use them, and all of the aircraft which drop them. The ballistic accuracy and delivery envelope of most of the existing bombs are no longer compatible with the overall bomb delivery capability of advanced supersonic aircraft, avionics, and skilled pilots. Also, increases in target types and hardness and new requirements in safety and logistics exceed the capabilities of the current general-purpose bomb. A new series of bombs, the Advanced Bomb Family, ABF, is being designed to replace the Mark 82 and 83 general-purpose bombs and will be introduced into the inventory as the War Reserve stockpiles of Mark 82s and 83s are depleted. The Naval Weapons Center, China Lake, the Naval Surface Weapons Center, White Oak, and the Air Force are cooperating to ensure full compatibility of the ABF on our aircraft and aircraft of the NATO countries. Central to the ABF are two new warheads, a 500-pound fragmentation blast warhead and a 1,000-pound penetration warhead. Aircraft carrier ammunition lists now show 35 parts for the current Mark 80 series bombs. These parts must be purchased, inventoried, shipped, unpacked, stored, broken out, and selectively assembled before the components collectively become a complete bomb. Bomb assembly is a major effort during strike-up. Although all-up stowage of Mark 82 bombs would significantly reduce the bomb handling effort, it would also reduce magazine capacity by 1/3 because of the added length of the tail fin. Additionally, all-up stowage of Mark 82 bombs is prohibited because the fuse lacks an environmental safety device. The two ABF bombs will come from the depot as all-up weapons. They can be stored in carrier magazines in a ready service condition because the fuse has advanced environmental safe and arming features. Because of the ABF's shorter length, these all-up bombs can be stored in carrier magazine space now used to store only Mark 80 series warheads. The improvements in logistics will reduce bomb handling efforts aboard carriers by nearly 70%. The basic fuse being developed at the Naval Surface Weapons Center will have 3 functioning modes. The fuse modes for the 500-pound fragmentation blast weapon are airburst, ground contact, and short delay. The capability to add long delay circuits for specific strike missions can be incorporated. The fuse modes for the 1,000-pound penetrator are contact, short delay, and medium delay. The 3 basic modes will be cockpit selectable. 17% of Mark 82 bombs, when released low drag, become unstable and fall short of their targets. The new tail assembly for the ABF will eliminate the low drag instability problem prevalent in the current Mark 82 bombs. The tail assemblies are collapsed to 1 bomb diameter for shipping, storage, and carriage, expanding to twice the bomb diameter following a signal from the fuse after bomb release. The same basic tail stabilizer is used on the 500 and 1,000-pound bombs. For high drag delivery, the 500-pound bomb has a cockpit selectable ram air inflatable retarder, which is internally stored in the tail assembly. These new bombs can be carried and released at all operational speeds through supersonic and from low altitude to maximum aircraft ceiling. The warhead case of the 500-pound bomb is made of standard low-carbon steel. It is internally grooved to achieve controlled fragmentation, thereby increasing overall warhead effectiveness. Though basically a fragmentation blast warhead, field tests proved the 500-pound warhead was able to perforate 12 inches of reinforced concrete at near perpendicular impacts. 8 inches is the maximum expected roof thickness on hardened industrial buildings. The thick-walled 1,000-pound warhead has perforated 48 inches of reinforced concrete, substantially backed by sand, at impact angles of 30 degrees from perpendicular. The 1,000-pound warhead provides a penetration capability not available in the current Mark 80 series. The ABF warhead can perforate ship targets, runways, and hardened aircraft shelters. The ABF fuse is designed to survive severe impacts and penetration, then function at an optimum delay time. Current Mark 82 warheads using Tritonol and H6 are stored in carrier magazines, either stacked like cordwood or palletized. There is little protection from explosive propagation. New pellets designed for PBX-filled ABF weapons will prevent explosive propagation should one warhead detonate. The bombs will be stored all up in carrier magazines. Therefore, separate storage isn't needed for fuses, stabilizers, retarders, or any other weapon components. The ABF retains the versatility of the Mark 80 bombs. The warheads can be used in laser-guided bombs, electro-optical weapons, glide weapons, and missiles. Versatility is the strength of ABF, with improvements in safety, effectiveness, and logistics, while providing compatibility with advanced aircraft armament and avionics systems not possible with existing bombs and fuse systems. ABF will provide the Navy and the Air Force with bombs designed for the tactical missions of the high-performance aircraft of today and tomorrow.